In the last video, we learned about inverse functions and determining if something is invertible given ordered pairs and graphs. In this video, we are going to find inverses of functions given different functions. Finding an inverse of functions of equations is very similar to what we did above, or in the last video, with coordinates. Again, with coordinates, we switched x and y. When we're talking about functions, we are going to still go ahead and switch x and y. To find the inverse of functions, we have a few steps that we go through. First, we're going to turn the function into an x and y equation. So turn function into x and y equation. So our function over here, h of x equals 2x plus 1, we're going to change h of x into y because we know that the function notation is interchangeable. So h of x is the same thing as saying y equals 2x plus 1. Our second step is going to be to switch x and y. So in this function, I'm going to switch x, so y becomes x, and 2x becomes y. Now I'm going to solve for y. So to get y alone, I need to use inverse operations. Here, I need to subtract 1 first from both sides, so x minus 1 equals 2y. And then I want to get y alone still, so I need to divide both sides by 2. And I get x minus 1 over 2 equals y. And my last step is to replace y with the inverse notation. So since I started with h of x, I'm going to turn this function into h inverse of x equals x minus 1 over 2. Or I could write h minus 1 of x equals x over 2 minus 1/2. Both of these are acceptable answers. So now let's do some examples. Finding the inverse functions here. First step, turn the function into a x and y equation. Y equals 2x plus 7 over 21. Now I'm going to switch x and y. So x equals 2y plus 7 over 21. And I'm going to now solve for y. I'm going to use inverse operations here. I'm going to multiply by 21 so I can divide out. So I have 21x equals 2y plus 7. I'm going to subtract 7 from both sides. And finally, I'm going to divide both sides by 2. So I get y equals 21x minus 7 over 2. My last step is to refer back to the inverse notation. So r inverse of x equals 21x minus 7 over 2. Now let's do a little bit of a more challenging example. Again, switch x and y, so y equals x plus 1 over x minus 3. So now I actually switch x and y. X equals y plus 1 over y minus 3. Now solving for y here, since I have a y in the numerator and the denominator, I'm going to go ahead and multiply both sides by y minus 3 to get rid of the denominator. So now, switching this around, x times y minus 3 equals y plus 1. I need to distribute this x in here. xy minus 3x equals y plus 1. In order to get y alone here, I need all the y's to be on the same side. So first, I'm going to subtract y from both sides. So I have xy minus 3x minus y equals 1. Since I only want y's on the same side, I need to get rid of this 3x. So I'm going to add 3x to both sides. Now I have xy minus y equals 3x plus 1. In order to get y alone at this step, I realize that both of these have a y in it. So I can take out a GCF of y. So by pulling out y, I get y times x minus 1. If I divide y out, I am left with x. If I divide y out of here, I'm left with negative 1 equals 3x plus 1. Now to get this y alone again, I need to divide the whole side by x minus 1. That will leave me with y equals 3x plus 1 over x minus 1. And finally, I just need to switch out so that I have inverse notation. Since I started with f of x, I have f inverse of x equals 3x plus 1 over x minus 1. Now, sometimes when I'm finding inverses, I have to keep in mind some restrictions. When dealing with exponents and roots, we have restrictions. So for a minute, let's think about the graph of f of x equals x squared. We remember that this makes a parabola. And a parabola has that U shape to it. So if I draw a quick sketch of f of x equals x squared, I have that parabola that goes through the origin. Now remember in the last video we talked about the vertical line test. Well, this passes the vertical line test. However, it does not pass the horizontal line test. So this is not actually invertible. So therefore, if I want to invert, you need to have a restriction. To find that restriction, we can look at the range of the original function. So the range of this function, starting from the bottom going up, first we start at 0 and we go to infinity. So we know that the inverse can only have 0 to infinity as its restriction. Or, if we take whatever's raised to the even power and set it greater than or equal to 0, we get the restriction. So since x is set to the even power, we set that greater than or equal to 0. So finding the restrictions of even roots, take what is raised to the even power, and set it greater than or equal to 0. Now, whenever you start with an even power, you will often be given the restriction, like example 4. G of x equals x minus 3 to the second power for x greater than or equal to 3. They found this restriction by using x minus 3 is greater than or equal to 0. So x minus 3 greater than or equal to 0, if I add 3 to both sides, I get to this restriction. So now, since there is a restriction, I can go ahead and I can find the inverse for this function. So replace g of x with y, so y equals x minus 3 squared. Now I'm going to switch x and y. X equals y minus 3 squared. Now recall back from last semester, to get rid of a squared power, a power of 2, we need to square root both sides. So I have the square root of x equals y minus 3. since the square root and the x and the 2 cancel each other out. Now, to solve for y, I need to add 3 to both sides. So I have the square root of x plus 3 equals y. And finally, I need to write it in proper inverse notation. So I have g inverse of x equals the square root of x plus 3. Now, for example 5, this function, we start with p of x equals the square root of x plus 7. When dealing with this function, we don't need to worry about restrictions because they are already there. The square root function only can have positive values put into it, so we know that the restriction starts with x greater than or equal to 0. So right away, we can just start with y equals the square root of x plus 7. Now switch x and y. And now we have to isolate y. So subtract 7. X minus 7 equals the square root of y. Again, just like getting rid of an even power, we square rooted both sides. But now, to get rid of a square root, we need to raise both sides to the second power. So we have x minus 7 to the second power equals y. And finally, we have to put it in correct inverse notation. So p inverse of x equals x minus 7 squared. Now this is where it's important. If you end with an even power, we need to find the restriction. So again, to find the restriction, we take whatever is raised to the even power and set it greater than or equal to 0. So x minus 7 is greater than or equal to 0. Therefore, by adding 7 to both sides, we get x greater than or equal to 7. And that is our restriction. We have our inverse function with the restriction that x is greater than or equal to 7. So when you end up with an even exponent, you must find the restriction. And to find that restriction, you're going to set whatever is raised to the even power greater than or equal to 0, and then you solve for x if you need to. Now, after watching this video, we want you to go ahead and try example 7 and 6 and bring it to class.